My name is Harley Means, and I'm a geologist, and I work with the Florida Geological Survey, which is a branch of the Florida Department of Environmental Protection. So behind me, what you'll see is the beautiful Aucilla River, and that's one of many of Florida's river systems. It actually has the headwaters up in South Georgia, and it flows down through Jefferson County and ultimately makes its way down onto what we call the Woodville Karst Plain, where the river actually disappears underground through a number of sinkholes and reemerges finally at Nuttall Rise, which is a few miles north of us here, and flows all the way down into the Gulf of Mexico. Geology is a broad science, and under the science of geology are subdisciplines, one of which is hydrology. And hydrology deals with water and the flow of water. And one of the things a hydrologist is responsible for doing, particularly here in Florida, is monitoring the amount of water that comes out of springs and flows in and down through rivers and discharges into the Gulf of Mexico, at least for the Big Bend region. And one of the things that they will do is actually try and calculate discharge, and there's a number of ways geologists can do that. One way a geologist can calculate discharge is to actually physically go out and use a device called a flow meter, which actually measures the current velocity in the river channel. And what you would do is you would tie a line across the river perpendicular to its flow, and you would take various measurements across the river looking to see how the velocity or the current velocity changes across the profile of the river. And then after you take all those measurements, you would average them together and you would get the average flow of the water. And then you would calculate the cross-sectional area of that. And you would do that by knowing how deep the water is at each point. And from looking at the cross-sectional area and the volume of water that moves through that cross-sectional area at a given time, you can tell what the discharge is. Q, which is the discharge, is calculated by multiplying the cross-sectional area by the average velocity of the current flowing through that cross-sectional area. Velocity is simply units of distance per time, right? So for instance, this might be meters per second if you're using scientific units, or it might be feet per second if you're using English units. So the units that ultimately describe what the discharge is typically expressed in cubic feet per second, but you can also express it as cubic meters per second, and hydrologists can calculate back and forth between those using what's called dimensional analysis. The reason you want to measure the discharge in a river system is, number one, it's important to keep track of how much water is coming down these river systems, so you can track things like when are you in a drought, when are you in a flood stage. The velocity of the water obviously is not constant throughout the water column, nor is it constant along the bed of the river or along the banks of the river, and that's partially due to the topography on the bed of the river. It's not uniform. So in other words, as the water passes over all these things on the bottom like rocks and logs and hits the bank and hits a cut bank, the water has to then slow down or speed up based on the encounter with those impediments. So as I said, the velocity changes as you go across the bed of a river, and that's why we want to calculate the average velocity when we're looking at a discharge. So the current velocity in a river system tends to be higher in areas like, say for instance, the outer bank of the river, where the river has to make a bend, and it forms what's called a cut bank. And on the inside of that bend, it tends to deposit material because the current velocity slows down. So another aspect of the velocity of a river is its ability to transport sediment. Rivers, particularly here in Florida, that flow through karst terrains, which are very low gradient rivers that don't transport a lot of sediment and are fairly slow moving, it turns out that when things fall into those rivers, oftentimes they can become preserved either in deep spots in the bed of the river, or they get preserved because sediment covers them over and doesn't uncover them because the current velocity is not sufficient to actually erode away that material. So when you go looking for things in Florida's rivers, say for instance paleontological or archaeological sites, you might look for a spot in the river where there's either a deep point where material could be deposited because current velocities have slowed down, or you may look for an area where you're on a cut bank and the river is actually picked up in velocity and is actively eroding into the bank and exposing new material. The bed of the Aucilla River can boast holding one of the oldest dated archaeological sites in all of North America. So there are plenty more sites to be found, and it's just one of many things that make the Aucilla River an exciting place for me to be anyway.